Okay.
Hi.
Welcome back. Hi. It's day 15. All of us are feeling great. I hope you guys are feeling great too, and staying away from other people. So let's update on the egg. So where we left off is we put it into salt water, and I think we've agreed that it has shrunk just a little bit.
Yeah,
Can we pop it in the water?
Please no. I think it's on its last leg. I think it's done. I
Yeah,
think
can
we'll.
we please throw it
Can we
away?
just pop it in the
I think we'll let it go.
You want to pop it in the cup?
Can I get a toothpick? Ew. All right.
Do it outside.
Then what I'd like to do is go over the think questions from the last reading. So last time, Thursday, I think, you guys were told to read. No. To read the discovery of friction.
I'm sorry.
It's all right.
I'll do that after this.
And so that basically just what are you doing?
I'm getting.
Toothpick, honey. Toothpick.
There were no toothpicks.
Yeah, there's toothpicks. This is a very small portion of the universe. The covered other side. No, that covered other side of it. Do you see the box? Yes. Just one toothpick, please.
Do it outside.
No, do it in here. It's fine.
Let's just
No,
keep
it's
it
not.
away from the paper, though.
Right.
Just
Keep it over there. All right. Here we go.
Okay, so.
Oh!
In the fountain.
Oh my gosh! Don't poke it again. Don't poke it again. All right, that's enough. Now we got a mess to clean up. Did you see
Nasty.
It's like.
that? All right. Nope.
Oh.
Put it in there.
Ew.
Yeah, put it. Let go. Okay, take this over the sink.
Gross.
Uh-huh. Yeah, I'm gonna do some cleanup. Be right back. Okay.
It now
We're back.
smells like pickled Sharpies.
Pickled Sharpies, because you know how I like to use my vinegar spray stuff, and then I put some alcohol in there to
Pickles.
make it more germ killing, and then a few drops of essential oil because it smells nicer. So in your reading, The Discovery of Friction, the 3 think questions. So the first one, how does the texture of a surface affect friction? You want to answer that? How does the surface affect friction?
It can increase the amount of friction or decrease the amount of friction.
Yep. So a surface that is sticky or bumpy, will that have more friction or less friction than a surface that's smooth?
More.
More.
And if it's squishy or softer anyway, then it also makes more friction.
Okay, so squishy, soft, sticky, rough, more friction. But smooth, like our tabletop, we don't have a lot of friction.
No.
Okay. What might happen if you tried to walk across the room and there was no friction?
Ice skating!
Yeah.
So you just slide?
Yeah.
But think about what it takes to take one step.
Oh, yeah, roller skating.
So you know that paddle when you've got wheels,
Literally.
you might just be spinning your wheels. You wouldn't be able to push yourself off the floor.
Yeah, you'd have to push yourself with your arms on the wall.
Yeah.
Yeah.
If there was no friction,
You just keep
then your hands
sliding.
would slide.
Right, you just keep sliding in the general direction, so you couldn't move. All right, and then it asks, what do you think Newton meant when he said, if I have seen further than most people, it is by standing on the shoulders of giants? So it talks about Newton's discoveries and what he studied. So he used to study Aristotle and Galileo, and of course I sent that article to you. He used those thoughts and stuff to observe the natural world, and that's how he came up with his laws. So those giants were other scientists and other observers of the natural world, and that helped develop his ideas so that he could come up with some new ideas.
Yeah.
Teachers.
Wow.
All right, so we are going to take a look at a chair. So we'll use this chair, and I'm going to move it over there.
Why do I have to give up my chair?
All right. So I need it here. I'm gonna position it down like that.
So you can actually see.
So you can actually see it. All right. I just gotta make sure that we can see it.
And then
All
I
right.
sit on it.
So without Emily sitting in it, all right, the chair's just sitting there. It's not moving.
I'm not
So
sitting in it.
how can we make the chair move?
You push it.
You push it. Okay. So how much force do you think you needed to make it move?
Well, more than 5 newtons.
More than 5 newtons.
Yeah.
All right.
I mean,
So, but wait, we're gonna go from the side, Emmy Ann. So you take one, okay, and Lucy, you take another, and Addie, you take another. So when you get to 5, you gotta stop.
Like, come
Okay,
this
other
side.
side. So that doesn't work. So Lucy, you add another 5. Don't go over 5 though.
okay.
Emily, move your knees. Oh.
Either of you going over 5?
No.
I'm trying not to.
You're like right at 5.
No, I'm like before 5.
You're like right before. So 4.8.
Yeah.
So they're each at 4.8.
So 4.8 plus 4.8
Uh-huh.
is
8.12
no.
or 9.2.
9.2.
No, wait, no, 9.6
9.6 what?
newtons.
Newtons, right? Because 4 plus 4 is 8.
Eight.
And then 0.8 plus 0.8.
Yeah.
Bumps it up to 9.
Mhm.
And then 16, right? 8 plus
Yeah.
8 is 16. Move the 1. Get it?
Yeah.
Okay, 9.6. Okay, so we got 9.6 newtons.
Pew pew.
All right. So when you exerted a force of 9.6 newtons on the cart, it moved. Why didn't it move when you just did 5 newtons?
Because it doesn't take 5 newtons to move it.
It
Because
takes-
friction.
Okay, so
The weight of the object also causes friction, doesn't it? The
because
amount
it's
of
applying a force pushing down, right?
Yeah.
The weight. So the
Yeah.
force pushing down, okay, versus
because like if Emily sat on it
oh,
and we tried to push it,
could we
would
move
be-
it with 9.6 newtons now?
No.
No.
4 grams.
All right, so that causes the friction to be more, right?
Try.
And you need more force.
No. Try to push self.
All right. Okay, so can you tell me why it didn't move with 5 newtons then?
Because the chair doesn't
Weigh that much?
the chair
There's more?
I
feel like pushing the answer, but I don't.
don't know how to say it.
It's
So the chair's weight causes friction on the hardwood floor,
Which also
that makes it
causes
harder
friction.
to move
Mhm,
also
the
causes friction.
surface, and it makes it harder to move.
because it's not as slick as no friction.
So what is it about 9.6 newtons? That's large enough. It's more of a force to cause what?
The chair to move.
To do what?
To
Push the chair.
to go over the friction.
To get over the force of friction. Right. Okay. So it overcomes friction. Okay. So now let's talk about multiple forces.
Wait, I have a question. Why, when we put socks on, we can slide on the wooden floor that has friction, but when we don't, we can't?
I think because your skin is sticky,
Yeah, our skin has friction.
right? And so
socks have less friction.
socks have less friction. So now I want to talk about, let's see how to do this. I want to talk about net force. Okay, and so our focus question for this is, how do multiple forces affect motion? All right, so how do multiple forces affect motion? So you saw with the chair, we needed 2 spring scales, all right, to overcome friction. Okay, Here's my diagram. And what is this picture of?
A chair.
A chair.
Actually, it's a bag Jenga set.
Thank you.
Yep.
You see, my artistic skills have not improved. Okay, so we have a chair, okay?
We have.
And if we assume that the chair is on a frictionless surface, okay, a surface with no friction, and we apply a force, which is F1 in this direction, what's going to happen to the chair?
It's going to move in that direction.
It's going to move in that direction,
Yeah.
right? Because there's no force to overcome. So any force that we apply to that will just slide,
Yeah.
right? Okay. Now, if we add a second force, this one. So I'm going to call this one F2.
Aw. You wanted it to be an E.
It's a force. It's our second force that we're applying. So if I put F2 there, right? Now, if F1 and F2 are equal in strength, what will happen to the cart?
It won't move.
Wait.
If they're equal in strength,
Can I look at the top?
Yeah,
if they're equal, it
If they're
won't move.
equal, it won't move.
it will move.
Yeah.
Yep, if they're equal, it will not move.
But if you were going with this is how much F1 has and that's how much F2 has, they have 1 force here and 2 force there, then it's going to move this way because there's less force on this side.
Uh-huh. Should we try it?
Yeah.
So,
Okay.
2 on that side and 2 on this side. Are you going to help, Lou?
Nope, she's taking a nap.
Just take it in there.
All right, so we're looking at newtons. I'm going to slide it this way a smidge.
Okay.
So the idea is I think we can get it to, you let go of that. I think we can get both of these to, the 4.5 or whatever.
I'm like, 4.
Can you take it all the way to 5?
Yeah. Where's you?
Okay, so I'm all the way to 5 on this side, and you're all the way to 5 on this side. Okay, and I'm going to let go.
Oh.
Oh.
All right. Cool.
Wow.
So when we had an equal force, right, they didn't move. So if F1 going in one direction and F2 going in the other direction is the same, it will be, it will not move. Okay, so 2 opposing forces act on an object. So 2 opposing forces, they're going in the opposite direction. They're acting on an object. Okay, the difference between the strength of the 2 forces is the net force, acting in the direction of the greater force. The net force can be thought of as the total of all the forces acting on an object. If F1 and F2 are equal, the net force is what?
Equal?
0. It's 0. So if F2 and F1 are the same,
Right. It was equal.
the net force is 0. Okay. What if F1 is 100 and F2 is 90?
Well, then F1's gonna overpower F2.
So F1 will overpower F2, and what direction will the chair move?
That way.
That way.
No, that way.
Whichever
Wait,
way
if
F1's
F1
going.
I know, right? The direction that F1 is going. It's directional, right? You got to pay attention. All right. Another way you can think about it if you define it, right, is moving in a positive direction and moving in a negative direction. Okay, they're moving in opposite directions, and if they're both equal, so for example, if we have 100 positive and 100 negative, 0, right? But if we have 100 positive and 90 negative, then you're going to move this direction.
Science and stuff?
Science and stuff. Okay, so we're resumed. That was a little interruption by Mr. Rudd coming in for lunch.
Dun dun dun.
So like we were talking, we've got 100 newtons in this direction and 90 newtons in this direction. We got a positive direction moving to the right here, and we have a negative direction moving to the left. this is going to end up moving to the right a little bit. And so you can kind of look at this two different ways. We've got one definition. The difference between the strength of the two forces is the net force acting in the direction of the greater force. But then we also have another definition that says the force applied in the direction, okay, force applied, let's see, the sum of the forces acting on an object is the net force. So we've got a difference, and we've also got the sum. Well, here's kind of the math. So you go 100 minus 90 is 10 newtons. But if you think about it, so that's the difference between the two.
Mm-hmm.
But if you think about it in terms of the sum, you've got 100 is the positive plus a negative 90.
Yeah.
Yeah, and so a trick to figure out negative numbers, if you change the sign on both of them. Oh, that didn't work. It's 190. Fail.
A 0.
0. All right, so you can find this by doing the difference. Sorry if I just confused all of you.
You're like,
I know. So moving in opposite directions, you can think about a positive and a negative. All right. Some other examples for you to think about. So if I push on the cart, right, in this direction, right, so I'm applying a force.
towards any direction.
You were not good at
Skywalker
pushing
be
that.
Yeah, okay, so I'm pushing on the cart
How are you pushing? What?
in this direction
She's pushing.
with a force of maybe 5 newtons. But it's not moving. Hey.
Oh, try this.
What's going on?
Well, the chair is more than 5 minutes.
Yeah.
So it's not about the weight of the
The
chair.
chair's friction is more than 5.
So it's not enough to overcome the friction. Okay,
Wait, keep
so
your hand up.
tell me, what's the net force?
Why? I'm more.
No, now you're moving it.
My hand's
Okay.
more than 5
So I
minutes.
want to not move it. Like I want to push on it with just enough to not move it. What's the net force?
5 minutes. 9.6.
This is tricky.
Yeah.
So
Maybe a
I'm
negative number.
pushing on it.
No.
Is it
Yes.
moving in an opposite direction?
No.
No.
Is it
0?
moving?
No.
Yeah, it's
Oh!
a net force of 0, okay? And you know this because if it wasn't 0, it'd be moving. Good? Okay. So, let's say I'm going to push with a force of 50.
Oh. Okay.
Okay?
Just.
And you make it not move. You ready? Okay, so what's the net force being applied on the chair?
A lot. 0.
0. Not a lot.
Yeah.
Right?
No, I was like force. A lot of force.
A lot of force, right? Okay. So, let's see. Now, I'm going to reduce my force a little bit, right? So we'll start with 500. Okay, here we go. So push 500 newtons, 50 or whatever. And now, what's happening now?
I'm pushing against you.
So what happened with the forces? What do you think the net force was? It was no longer 0.
No.
So which?
How much force do you have, Addie?
No.
Not a lot.
Not much.
So your force could stay the same.
Yeah.
My force decreased,
Yes, it did.
right? And so if we add those together, the force applied in this direction was greater, so it's going to move in this direction.
Yeah.
Okay. Yeah. Okay, cool. Now, one more example. We're going to point this towards the door. Okay, and I'm going to do this. Yeah, can we see that? Okay.
No.
So now,
That door doesn't have very much strength.
what is the net force?
Don't dent the door, Mom.
What's the net
Zero.
force? It's 0. Here, come help me push.
Okay.
Apply 5 newtons of force. Come on, push.
Ah!
Here,
Okay,
I'll help
friction
you.
is not very strong. What's the net force?
0.
0.
No, I'm
Okay.
not done. I need to help you. Come on, Addie. We're gonna do this.
All right, so thinking about that, right? How much force is the wall or is the door applying?
A lot.
A lot.
Well, not really.
0.
No, because if it was 0 and I was applying 500 newtons, and I don't know how much force we were applying together, but how much force do you think the wall
The
is applying?
equal amount.
The equal amount, because the net force is,
0.
and we know that because it didn't.
Move.
Perfect.
And I'd be scared if the door decided to push back.
Right. Right.
I have to call the Ghostbusters or something.
Right. All right. So we are going to take a look at notebook sheet number 5 and 6. So,
Let me see this.
yeah, you guys come on over here. We'll kind of set up shop here.
Oh, it's on sideways. It's on sideways. It's sideways.
Yeah, so this is multiple copies. So this is number 5, forces on carts A.
Nice, me.
And then over here we got forces on carts B. Okay.
So are we supposed to predict what's
We're
gonna
just
happen?
we're just gonna discuss. So
That's a man, right?
we've got
Man A, woman
5
A, child B.
we've got
child
5
A.
situations. Okay. So and do you want to use this to help you
Sure.
draw it?
I like drawing.
Uh-huh. Okay.
I've been drawing all day.
Yeah.
I actually have.
I know. Okay. So our first situation is that. Why don't you come over here? Okay. So our first situation is in class. Students like you guys learned that a cart will move when a force of 50 newtons or greater is applied.
Yes. Okay. So.
A student pushed on the cart with a force of 10 newtons.
Weak.
That's not a strong person. Yeah.
So the cart did not move.
that's
So draw that.
two of
So
these.
I'm
This
drawing this
person-
guy failing miserably.
This
Yes, you're
person
drawing a
has
guy failing.
This much force in his
Okay,
life.
and you're drawing it quickly
Oh, okay.
because it's already here. So they're pushing on a cart, and it will only move when a force of 50 newtons or greater is applied, and the student pushed on it with a force of 10 newtons.
You know I can't draw stick people.
Mm-hmm. I like the little sweat drops. Okay, show me an arrow with the force applied.
It's also like way bigger arrow going this way.
Okay, that's interesting. All right, so we got this, right? And so this guy, go ahead and label 10 newtons.
Okay. So this guy right here, he has 10 newtons because he's a weakling. And,
Do 10N.
oh yeah, good point. Labels.
Labels, kittens and mittens.
I like kittens. I don't like mittens though. I think they're kinda
Okay.
stupid.
So then,
Or like socks for your hands.
so
They are
you got
socks for
10
hands.
newtons. Okay. And so what's the opposite force?
50 newtons. 50
Okay.
plus newtons.
If
That's how.
this was 50 newtons,
Yeah.
where would the cart go? It would go that direction.
No, okay, hold on. I drew the arrow wrong. It would be going down. Going down. 57.
So does that mean the cart is gonna go like here?
Oh.
That's a bad arrow.
So the question is,
Stop shaming her drawing.
is
abilities.
the cart moving when he applies 10 newtons of force?
No.
No.
So what's the net force?
0.
It's 0.
Oh my god.
So what's going on?
It's not moving.
It's not moving. The net force is 0.
The
So
friction.
it's not.
I don't know where
Yeah,
to draw the arrow.
you're right. So they're really
So you put the arrow back where it was, but it's 10 newtons.
right.
Oh.
And so maybe we want to put the arrow like here, right?
Yeah.
And so it's there with 10 newtons.
Wow.
That's
Yeah.
an
Okay,
Emily-
so it needs 50 to overcome. But it is applying the same force back. All right. Number 2.
Oh,
Actually, it
goodness.
only
Go ahead and
needs
erase that.
11 to overcome.
Student A pushed on
Can I
the
do
cart with
No.
Student A pushed on the cart with a force of 500 newtons.
What the?
Student B pushed on the other side of the cart. The cart did not move. Draw me a picture.
Okay.
Oh, sorry.
Give me back my marker, you thief.
Mm-hmm.
So we have
I like to
Mr.
steal
Cart.
markers
Yeah, this Mr. Cart
and
here.
pencils and pens.
Me too.
Okay, here we go.
Family. Stop yelling at me
Student
for stealing
A.
your pens.
Pushed on the cart with a force of 500
Do you have any
newtons.
markers?
Yes, in
So
the
we-
drawer.
So we draw a really buff dude. It's a girl, and then we draw another really buff dude. Buff girls exist. I guess you shouldn't stop saying buff dude. And they're pushing.
Draw me an arrow. Give me labels.
Okay, that's an arrow, and they have 150, right?
500 newtons. Student A, 500 newtons. Student B on the other side. The cart didn't move.
That means that this guy also has 500 newtons.
Okay, but your arrows?
Where'd the X go?
Oh, they're pointing in the wrong direction. Sorry.
Oh, that's a buff too.
Uh-huh.
My card.
Ah,
Yay!
okay. So, we got this.
Mustache man.
So, this guy's pushing student A with 500 newtons. The cart doesn't move. So, we know then if it's a net force of 0, this has to be 500 newtons. Perfect. Number 3.
Ah!
Student A, you don't have to erase all that. Just think about this. Student A pushed on the cart with a force of 400 newtons.
Okay.
So 400 newtons with this guy.
Okay.
Student C pushed on the other side of the cart. So this is student C
Yeah.
pushing on the other side, and the cart rolled to the left.
Wait. Okay. So
What side is student
they-
A on?
Student A is on the left side
And how fast is he going?
400.
with a force of 400 newtons.
So
Student
that means student
C-
C is bigger than 40. So it
Not necessarily bigger, but
Stronger. Like
applying more force. So, and it
500.
rolls to the left.
newtons.
Okay, so it could be 500 newtons. So student A moving in this direction in 400 newtons. Student B moving in this direction, applying a force of 500 newtons. So it's going to be moving in this direction. Now, my next question is going to be, what's the net force?
100?
Assuming that's 500, it'd be 100.
It'd be 100 newtons in what direction?
100 newtons going left.
100 newtons in this direction, which we could demonstrate with like a negative.
Oh! My brain just said, yeah.
Does that work?
Yes.
Okay. Can I see yours?
Yeah.
No.
Wait.
Nope, give it. Here we go.
No details times ninjas.
Okay, so
What?
we got
I can't write
400 newtons, we got 500 newtons,
right there.
100 going left. 100 newtons going
100
left.
plus going left.
100. Oh, it could be 100. It could be more than 500. You're right. All right, so now we're going to look at page 6. All right. And so page 6 says, so this is our fourth example. Student B pushed on a cart against the wall, like we did with the chair.
Okay.
Okay. Pushed on a
Oh,
cart
okay. Hold
The wall
on.
be
I'm
right.
coming.
against the wall with 500 newtons of force, and the cart didn't move.
Oh, big surprise. Okay, I don't understand. What is it with walls in this family? But first T-Rexes liking walls, and then
All right, so student B pushed
This
on a
person's
cart against the
weird.
wall. I'm gonna simplify it just a little bit.
Aw.
Okay, give me an arrow and label it. We got 500 newtons of force.
So 500 newtons.
Uh-huh.
And
Okay.
Since it's not moving, then this would be pushing back with 500 newtons.
You got it. Net force is
It looks
0.
like soon.
Okay, so 500 newtons going that way. And since it's a net force, the wall is 500 newtons that way. Now, that's not saying that the wall isn't stronger than 500 newtons, but it doesn't have to exert a force greater than that to
No.
stop this from moving it.
Yeah.
Yeah.
It's just like, stop.
Yeah, equal and opposite.
Yeah.
Like your wall over there, Em.
I'm brilliant at building walls.
All right, now here's a really complicated one. You ready?
Wait, no, you didn't get to show them my wall.
Give it to me then.
Give me your wall.
And my person.
Nice.
All right.
Great person.
There we go.
My marker doesn't work.
See the
very well.
wall?
Yes.
500 newtons going that way. All right, now if this person were really strong and they applied 1,000 newtons to this wall, perhaps it could bust through.
Whoa.
But
All right.
It doesn't look very strong.
Number 5.
Mm-mm.
Student C pushed on the cart with 400 newtons.
Okay.
Student A pushed on the cart with 1,000 newtons of force.
Okay.
And student B pulled on a rope attached to the cart with 500 newtons of force.
Where's the student B?
All right.
Yeah, which side student
Student
be on?
C is on the left-hand side.
Okay, so we have cart,
Mm-hmm.
Mr. Cart. And you have student,
Student
C.
C.
I'm just going to draw a stick figure. because
Yeah,
I'm
pushes
thinking-
on the cart with 400 newtons.
So he's going this way with 400 newtons.
Mm-hmm. Student A is on the opposite side,
Student A
pushing
is
on the cart with
this.
1,000 newtons of
Guess
force.
what? You got a B in your
1,000
face.
because
A.
he's a...
But student B is on the same side.
Wait, what?
Student B is on the same side as A,
Yeah.
and they have a rope attached to it,
And
Wait,
they're
who's
pulling
and
that
they're
way.
pulling that way. They're pulling in the
So
same
the arrow would
direction
go that
as
way.
students. So, okay,
Hold on,
So-
I need a new marker.
it is.
My marker sucks.
Yeah.
And it doesn't come off without screws.
Where's the red one that was in the drawer?
And he's pulling with how
In
much
my drawer?
force?
Oh.
How much force?
500.
500.
Mm-hmm.
So, okay, math and stuff. Oh, okay.
Oof. Yeah, go ahead, math and stuff.
Okay, so Mr. A
Mm-hmm.
and Mr. C,
Mm-hmm.
I'm going to assume that's what they are. Mr. A and C are on a team. They're going the same direction.
And C.
They're going the same direction.
Going in the same direction.
I don't know which direction that is, but they're going that way. And so, you add their combined efforts together because they're going the same direction, which would be
400 and 500. 900 newtons. Okay, great.
which is 100 off from 1,000, so Mr. B would still win.
Okay, so Mr. B is moving in this direction, 1,000.
Mr. B.
Mr. B, hey, Mr. B. All right, so the cart is going to move this way
Yes.
with 100 newtons of net force.
Yes.
Excellent.
The whole time the box is like, help me.
All right. Okay, so hopefully you were able to follow along with it. That's it for that. Now, your challenge is to create a situation, a story problem like that, and post it in the comments.
Okay.
And then if enough people comment, hopefully you can solve this situation and tell us what will happen to your object that a force is being applied to from either direction, whatever you decide to come up with.
Wait, I've got one.
we just
Also,
talk
there
more?
is a practice website. It takes you through maybe 5 questions in a certain amount of time. So I've shared the link in the Google Classroom as well. So
Yay.
I look forward to your comments. Hope
I
you're
better
having
go
a great
do that
day.
now.